All right, so what we're doing today, we're just going to add to our Chapter 6, Section 6 notes. So if you're watching from home, make sure you have already viewed the Chapter 6, Section 6 for the perfect square trinomial. This just goes right underneath that same heading. So this is kind of the Part B. So no new heading. I just need you to go ahead and write everything you see on the board, and that is what we're going to add to what we already started with. So the class has already done this. We're going to move on. If you're watching from home, please pause, write everything down, and then rejoin us. So a binomial in the form of a squared minus b squared is called a difference of two squares. And in my opinion, this is the most important out of the two. So when it comes to special circumstances when multiplying polynomials, this is by far more important for you to know than a perfect square trinomial. The thing about a perfect square trinomial, you can get to the answer by multiplying longhand. You can factor even if you don't realize what you have is a perfect square trinomial. You're still going to be able to factor it just fine. But whenever it comes to a difference of two squares, you kind of have to know your stuff. So once again, you can get to it the longhand multiplication. You don't have to shortcut, but the factoring part is what's important. So if you work on the shortcut now, it'll make the factoring easier because you're going to recognize how I got to a difference of two squares. So let's look at this definition here, the part that says a difference of two squares is formed from the product of multiplying a plus b times a minus b, and that gives us the difference of the two squares. What do I mean by squares, by the way? What is a perfect square? What is a perfect square? Basically, it's a number that was formed by multiplying something by itself, right? 64 is a perfect square because its square root is 8, and then 36 is a perfect square because it was formed by multiplying 6 times 6. 25 is a perfect square because it was multiplied 5 by 5. So a squared is a perfect square because we multiplied what? A times a. B squared is a perfect square because we multiplied b times b. No, this negative is just the difference part. So we have a difference of two very perfect square numbers. The difference will always be there. So let's look at how this happens. So you remember when we're talking about a perfect square trinomial, feel free to go get a drink beer if you need to. Oh. Go ahead, babe. We'll open it. Okay. So last week we were talking about a perfect square trinomial. Remember me talking about the fact that we had perfect squares on either end? Okay. We had the perfect squares on either end, and then we had the cookie in the middle, right, or the goodie in the middle. We had the two cookies, and then we had the goodie. So like the double stuffed Oreo.
Yeah, I love it so much.
So here we only have the cookies. Where did the double stuff go? Somebody ate it. Why? Let's look mathematically why the goodie's not there. So if I take a times a, there's the a squared part, right? But then when I take the a times the negative b, I get negative ab. And then I take b times a and I get plus ab. What's going to happen with these two terms? They cancel each other out. And then I have a b times a negative b, and I get a negative b squared. They're multiplied here, not added.
Oh, okay.
Okay, we got it. Let's look at number 1 example. X plus 8 times the quantity of x minus 8. Let's do the longhand so you can see the terms cancel out from here on out. We're going to go ahead and do the shortcut because now we've identified, hey, they're just going to cancel out. So x times x gives us x times negative 8, negative 8x. 8 times x, and then 8 times negative 8. What happens here? They cancel out. So we're left with simply, can I give you an every time scenario? That's going to happen every time. Every time you have two terms, the exact same terms in the binomials, the only thing is that one of the signs is going to be different. And that negative technically can be anywhere in one of those binomials, but we can only have one negative. Only one of the signs can be different. Then we're going to have that same scenario where we square the first term, square the last term, and it's always a difference of, right? It's always going to be negative. So number 2, I want you to do that using the long, well, no, I want you to do it the shorthand way. Do the shortcut. I'm going to pause so you can do that at home as well. Okay. Do I have a 3 in both of those binomials as my lead term? Do we have a 2y squared and a 2y squared? Is one addition, one of them subtraction? We're set up to have a difference of 2 squares. I simply square the 3, which is 9, square the 2y squared, and that becomes 4y to the 4th. Don't forget the exponent. And then subtraction. That's it. That's it. How about number 3? 9 plus r times 9 plus r. Will I get a difference of 2 squares? Why not? Why will I not get a difference of 2 squares? They're the exact same. That's squaring a binomial is what we're doing, aren't we? That means we're going to get a perfect square trinomial, which is, remember our cookie? Square the first term, square the last term in the middle, multiply them together times 2, and we get, so we have 81 plus 18r plus r squared for that one. So be aware, they may throw in a squaring of a binomial instead of one binomial that's addition and one binomial that's subtraction. So just be very aware of that when you go to work your problems out today. For most of them, you're going to wind up with a difference of 2 squares. Make sure that those 2 numbers are actually squares. Make sure you didn't make an error with the exponents, yes. If you want to, yes, but just be aware of what your answer gets and where that came from, because when we start factoring, you need to be aware that this breaks down into square roots, one that's plus, and then one that's minus. So you have to be very cognitive of where that came from so that next chapter when we get into factoring, you know how to factor it back apart. Like 3? Oh, because you weren't here on Thursday. Yeah, I'll do some more like 3 for you on Thursday. So the rest of you, I'll go ahead and give you your assignment. That's it. Page 437, 14 through 19, 33 through 38, and then 48 through 52. On the front board, I have the review that we're going to start tomorrow. You'll be working on it both tomorrow and Thursday, but we're going to be grading halfway through on Thursday, so you only have maybe 20 minutes in class on Thursday to work it. So if you finish today's assignment, I suggest you get started on the review to keep you from having any homework all week long. That's the review right there. I don't recommend you doing it tonight because then you have nothing to do in class for the next 2 days. But you're going to have time left over today, so you might as well get started on it to keep you from having homework later. I have a test ready for you for Friday. It's a notebook test. It's open notes. The questions from that are going to be directly from the notes that I gave you. So that means the example problems that we've had, the vocabulary are exactly the vocabulary I've had on the screen. So as long as you took good notes, you're going to have a really good time on that quiz Friday. If you paid attention but yet you don't take great notes, then you should do well too. You should be able to work out the problems. But if you have good notes, then you're going to be able to just copy those problems down directly from your notes. The reason for me to do that is to make it easier for me to grade your notes. Some of your notebooks are very neat. Your handwriting is very pretty. Some of you not so much, but you still have the material. So this gives me an easier way to grade your notes. That way I know you've got your notes. Or if you're not a very good note taker, but yet you pay attention in class, you're still going to do well on the quiz. So it's kind of a win-win for everybody as long as you're doing what you're supposed to in my class. The test for this chapter is going to be next Monday. I don't like Monday tests, but this was a short week, so Monday is when our chapter test will be for this. I didn't want to rush it either. I didn't want to rush it in on Friday or even rush it for Thursday, so it'll be Monday. It will be Monday. So that'll conclude for this lecture. Make sure you do pull up both the schedule that I have on Edmodo if you're watching from home, that way you can see what's going on, and pull up the lecture from Chapter 6, Section 6, so you can get the notes for a perfect square trinomial.